All right, this is problem number 11 from section 2.7. These two functions are defined for us. We're supposed to find each of these combinations and then find their domains. So f plus g, so I'm going to add them together. It's 5 minus x. There's f. G is x squared minus 3x. And it's f plus g, so add them together. And then I'm just going to combine some like terms. X squared, negative x minus 3x minus 4x, and then plus 5. And notice for domain, I'm not dividing by anything, I'm not square rooting anything, so it's any real. I think your book might write negative infinity to infinity, write that set notation, means the same thing. The next one, f minus g. So f is 5 minus x, and I'm going to subtract x squared minus 3x. Notice all of f minus all of g. So then distribute that negative into there. So I have 5 minus x squared plus 3x minus a negative. Combine some like terms. I get negative x squared. Negative x plus 3x is plus 2x plus 5. Again, I'm not dividing by anything. I'm not taking square root of anything. So it's any real number. Your book might write it like this. That just means from negative infinity to infinity. All right, f times g. So f is 5 minus x, g is x squared minus 3x. You could set it up in a rectangle to multiply it, whatever you like. I'm just going to FOIL it. X squared times 5 is 5x squared. 5 times negative 3x, negative 15x. Negative x times x squared is negative x cubed. And negative x times negative 3x, negative times negative is positive, 3x squared. Throw together some like terms. I have a negative x squared. 5x squared plus 3x squared is 8x squared minus 15x. Again, no division going on, no square roots. So it's any real number. And if you do it in that set notation, this means the range from negative infinity to infinity. And the last one, f divided by g. That's going to be 5 minus x divided by x squared minus 3x. And I'm going to factor this just in case, just to see if anything cancels out. I don't think it does, but yeah, nothing divides out. So I can leave it like this, I can leave it like that. Here's the trick though. Now for my domain though, I can't divide by 0. So I know that x cannot equal 0 or 3. So I can write my domain that way, and that's just fine. What your book probably wrote is going to be a little ugly, but it basically means the same thing. Your book, it looks like in the answers, wrote the set from negative infinity to 0, not including 0, unioned with the set 0 to 3, not including 3, unioned with the set 3 to infinity. So all this means is like you have this range from negative infinity to 0, so anything less than 0, but it doesn't include 0. If it did include 0, they'd write that type of bracket. Union with, combined with the interval from 0 to 2, but it doesn't include 0 to 2. I'm sorry, not 2, 3. And notice that I just wrote x doesn't equal 0. That means the same thing as this gap right here. And then combined with this interval from 3 to infinity, not including 3. So again, notice 3 is a gap here. So this is the same as this, and I would never ask for this notation. Just give me that.